Hello students, welcome to Misostudy video class, and as it is clear from this first slide, today we are going to discuss some good questions based upon JEE Advanced Pattern exam on the basis of, you can say, old questions, some change questions, and the topic is class 11th, very important topic, that is oscillations. So together oscillation with waves in class 11th, it forms a very you can say important unit of your competitive exams. Almost 2 to 4 questions because it is advanced pattern. So obviously you can say the pattern of the questions varies. It may be matrix match, it may be more than one option correct, it may be like only one correct option, it may be paragraph based, it may be integer based. So various types of questions, as you know, IIT professors love to ask. So that's why I will also try my best to accommodate all those type of questions. So what we will do, we will try to explain all these questions fine for this JEE Advanced Pattern, and that too from the oscillation chapter one by one. First I will explain the problem, then I will provide you the solution. The remarkable things are two in this entire video. Number one, the solutions that I will mention on this green board, they may be short. Reason, detailed solutions are present in your ebook. Fine. So here we will you can say explain some important aspects, fine, for your you can say brush ups of the basic or building of the concepts. And second aspect is, please keep revising, do some practice, fine, without watching the solutions. First you can watch, understand, then repeat it. Just run the question, wait, stop the video, try yourself, only then move ahead. So with this two positive suggestions, let me allow to start this discussion of JEE Advanced Pattern exercise. So here it's your first question. The question is not big, and here a very beautiful concept that we are going to utilize. I will tell you what. The question is, these two blocks P and Q, a block P, this one, of mass small m, fine, the block P is small m mass, is placed on a horizontal frictionless plane. This is your horizontal frictionless plane, smooth plane. So as such, no force of friction is acting. A second block of same mass, means Q is maybe smaller in size but mass is same. So it is also small m. It is placed on top of it. And now this upper block is connected with a spring. Okay. So the two blocks are pulled by a distance a, like this, you pull this, fine. Block Q oscillates without slipping. Q oscillates without slipping. Reason is, if you just take a look, frictional force between this coefficient of friction between Q and P surfaces is present. So because of that force of friction, Q and P will remain in contact up to a specific amplitude value, fine. So block Q oscillates without slipping. What is the maximum value of frictional force between the two blocks? This question is a very beautiful combination of laws of motion. Block on block system to find the maximum force so that both the blocks may oscillate together. This is a very, you can say, well-known problem, or normally any teacher teaching physics normally used to discuss this type of concept, block on block system, during the discussion of laws of motion. So here one more aspect has been combined on block system. Imagine the possibilities that we can put over here. Make this surface with some friction, then situation will be changed, fine. Or you can say in this situation, like Q is pulled only and then the oscillation is taking place. Various possibilities are there. You may attach one more spring over here. So all these possibilities, when I am going to explain, definitely I will not explain you all possible combinations, but here I will only provide you the approach for this problem, but you should keep in your mind this thing, fine. And whenever you have time, you can think like that, because JEE advanced pattern, it is mentioned for this exam, no question at any point of time is going to be repeated. Only every time new questions based upon concepts. So let's start this discussion with this assumption that it is given both blocks have same mass, and block Q and P there is a coefficient of friction, means frictional force is acting, that's why both the blocks may move together, fine. So as you know, here no space is available, so what I will do, I will take a turn, use space available over here, and in this explanation if some portion of this question is hidden, I hope you will not mind it, okay. So let's start. Angular frequency, that is angular frequency of system. System means system means P and this Q, P and Q together, these two blocks. So angular frequency of system omega is equal to, because the concepts of basics of this oscillation chapters, I hope you are continuously revising. So directly I am writing this equation, that is K by M plus M, sorry, M plus M. Now both the masses are same, so you can say that it is 2m, fine. I hope this first step is clear to all of you. Now maximum acceleration, I think I should do one thing, let's use the color of different chalk, that way it is going to be easier for you to understand. Now maximum acceleration is given as A max is equal to, obviously we are talking in terms of maximum acceleration of the system P and Q. So maximum acceleration A max is equal to omega square A, well known relation, we know that, fine. So omega square A, or what is the value of omega? K by 2m under root. So square means at this place of omega square you can write K upon 2m into A, okay. So what I will do, I will write down this using a white chalk so that you can feel the difference, that is Ka upon 2m, fine. Now lower block, that is P, that's why I am always trying to be near the question, so that at some point of time if it is required I can show you. So lower block, imagine the lower block will get this acceleration, fine, due to friction. Actually this acceleration in terms of this frictional force, lower block will experience that. So what I will do, I will write down this A max over here, just that is A max is equal to Ka by 2m. Now let it be remain over here, we can use this space now after cleaning for the further explanation, okay. But ultimately this term is going to be very important for us. Right now we just mentioned two terms. So what is this next system? That is lower block will experience this force, and why? You know the reason, because of the friction. Fine. So lower block will experience this force. So F max, because of the friction I am using this F. So F max is equal to M A max. No problem. Fine, for the lower block. Now it is something which I can write down M omega square A. So you can very easily say whatever we learned in the initial stages of this chapter, I am just utilizing those concepts. Fine. So this question, I mean ITJ advanced pattern question, they are not difficult. They just check how much you are comfortable in basic concepts. Fine. So F max is equal to M A max, and then replace the value of this M A max. So from here what I can say M. Fine. And then this value of A max, so either directly put the value or change the value, it's up to you. So you can say Ka upon 2m, fine, into this A value. So if you solve it, then m and m cancel, and ultimately you will get the value of Ka by 2. Now here I would like to mention one more fact. Few of you may get confused, what about this A? This it is completely, because what was the value of omega square? Under root k by m. So under root k by m means k by 2m. That was the k upon m plus m I mentioned in the starting. Then I rubbed that m plus m, I mentioned 2m. Fine. So from there, so this m and m gets cancelled. So ultimately, what is the maximum value of frictional force? So F max is equal to Ka by 2. Okay. So this way you can say A is the correct option. Very simply I explained this question so that you can understand it. Now let's move for question number 7. And yes, few of you may think why the discussion is started with question number 6. If you are regularly watching, obviously this question is not coming in your mind. But if you are not regularly watching these videos, then definitely this question will come in your mind. It is because first set of 1 to 5 questions we already completed, and I hope regular students definitely enjoying that video. Next sequence it may be 11 to 15. What we are trying to do, if one go we will give you like 40-30 questions, definitely you will not able to find yourself in a comfortable position. So what we are doing, we are just picking a small set of questions, proper explanation, and then close the video, so that in just 35 to 40 minutes, fine, you can learn, you can enjoy that learning. So here it is, question number 7. This is second episode of this serial. Fine. Next episode, depending upon that, obviously you will enjoy. So two bodies M and N. Okay. Let me give you just a quick, simple diagram. Body may be M and let's say body N. Just to show you the difference, that these two bodies are different. One is M, another is N. Any shape. Of equal mass. Okay, so mass of body M is M, let's say, and mass of body N is also M. Similar. Masses are suspended from two separate massless springs of spring constant K1 and K2. Now it is the situation that there are two springs K1 and K2. So with K1 let's say M is attached, with K2 let's say body name N is attached. Okay. If the two bodies oscillates vertically this way, such that their maximum velocities are equal. Maximum velocity in oscillations A omega. Okay. So maximum velocities are equal, then the ratio of the amplitude of one body to the vibration of this second body. Now a question can come in your mind. Masses are same, then why the amplitude is going to be different? Because K1 and K2, springs are not same. Springs are same, masses are same, then shape of the body is definitely not going to affect the oscillation. But here masses are same but springs are different. So that's why this difference is there, and then we will try to find out what will be the approach. Okay. So let's imagine this situation. Vm max is equal to Vn, sorry, it should be capital M. Vm max is equal to Vn max. What is the meaning of this? Maximum velocity of the body M equal to the maximum velocity of the body N. Fine. Now, you know what is the value of maximum velocity? Just I told you, A omega. Fine. Let's write it down. Omega m, am, angular velocity of body m, amplitude of body m is equal to angular velocity of body n, amplitude of body n. Fine. So omega m am is equal to omega n an. Now, what is the meaning of omega? You know that t is equal to 2 pi upon omega, or omega is equal to k by m. Forget anything. Fine. So am upon an, very simple question, slight twisting, nothing else, is equal to omega n by omega m. Omega n by omega m. Fine. Now, omega, let's use blue chalk, omega n is equal to under root k2, yes, k2 by m, because n is associated with the body number 2, and similarly omega m is k1 by m. Fine. So when you put the values of this omega n and omega m, so just take a look, this blue color expression will provide what type of changes? Then you can say, by putting the values and solving, you will get it as k2 by k1. Simple. Fine. And this is why, because this replacement of values. Fine. So am upon an is equal to under root k2 by k1. Now if you take a look over here, option number B is saying I am the correct option. Option number D is when you have to talk in terms of ratio of n to ratio of m. I explained you the method, very simple question. If I was supposed to design this question, then definitely what given in the question, I will definitely change that, and then I'll say maximum velocity of 1 is equal to n times of maximum velocity of second. Find the value of n. So it was in my mind that to change the question like this, but then I thought few of you who are still not regularly watching our videos and up to some extent feeling slightly uncomfortable in basics, so they may feel some difficulty. So I thought it's better to represent the question in a simple manner, and next time whenever we are going to give you third episode of this serial, then definitely I will incorporate those changes. Fine. So now let's move on to question number 8, which is a very interesting and simple question. And what is that question? This question, it's not a big one. First we will try to find out what exactly we are supposed to do. So read the instructions. Question 8 to 10 means question number 8, question number 9 and question number 10. One or more correct options. Maybe one option correct, maybe more than one option correct. Because this is the just second pattern of the JEE Advanced exam. Initial 4-5 questions, only one correct option. Second category is 3-4 questions where more than one correct options may be possible. 1 maybe, 2, 3, 4 maybe. So what are the options that we will definitely analyze later on? First we will try to understand what is given in the problem. 3 simple harmonic motion means 3 SHM in the same direction, 1, 2, 3, in the same direction they are going, having same amplitude and same period, fine, are superimposed. If each differ in phase from the next by 45 degrees, then now if 3 simple harmonic motion having same amplitude, same time period, but phase difference is pi by 4 and they are superimposed, so what are the equations of those SHMs? First we will write down that. So from here, and right now you need not to take the look of these options, fine. So even if I am coming like this and writing like this, please don't mind it, because this is something which is right now not relevant. First we will try to follow the instructions given in the question, then one by one I will explain you the options. So as per the question, 3 SHMs. So let's say y1 is equal to a sin omega t, a sin omega t, fine. y2 is equal to a sin omega t plus 45, pi by 4 or 45. y3 is equal to a sin omega t plus 90. I hope this is clear to everyone. First is this, second similar to this but phase difference 45 degree or pi by 4 with the previous one. Third is everything similar but phase difference more 45 from the second one, so on, fine. So these 3 equations when you combine, so y is equal to y1 plus y2 plus y3. This is superposition. Now you are preparing for advanced JEE exam, so mathematics is a very simple thing for you. So I will not use that particular formula, trigonometry and whatsoever. Directly I will write down the expression for the superimposed y equation. Okay. So now these equations are part of your this calculation. So let me allow to write down y is equal to whatever I am going to do over here, this plus this plus this, fine, I am doing that. So I am writing it as y is equal to root 2 plus 1, fine, sin a sin let's use this space because I have to show you again and again these options in the solution. So if I'll move away, it's going to be difficult for you. First step I explained over here. So finally y is equal to root 2 plus 1, then a sin omega t plus this 45, that is a, the way I mentioned, sin omega t plus 45, fine. So root 2 plus a, that is a sin omega root 2 plus 5, or you can say it is a sin omega t plus 45. So now what I can say? I can say this big A is nothing but this root 2 plus 1, fine. So A is equal to root 2 plus 1 A. This is the amplitude of resultant wave, fine. So A is equal to root 2 plus 1, which is differ by pi by 4 to the relative previous expression. Fine. So amplitude is root 2 plus 1 into a. Now let's try to find out, is it given? Okay. So let's start reading the first option. The resultant amplitude is 1 plus root 2 into a. Same we received. So what we will say? We will say option A is correct one. Okay. Now phase of the relative motion relative to the first is 90 degree, which is not correct. It is pi by 4. It is not 90 degree. Fine. So this B is not correct. Let's move ahead, analyze C and D also. Now C and D is saying the resultant motion is not simple harmonic, which is also incorrect. Resultant motion is simple harmonic. Fine. Resultant motion is simple harmonic. So this is again incorrect. It is not. If this is not, then it is correct. But it is saying not simple harmonic, so it is not correct. Incorrect. So only option left C that we have to check. Okay. Let's try to check it. You know, students, energy in SHM is directly proportional to A square. Means energy oscillates and it is directly proportional to A square. So E is equal to half m A square omega square. General relation of the energy. Fine. From here what we can say, E resultant means that resultant simple harmonic motion you are getting by combination of y1, y2 and y3 upon E single, means any single one, either y1, either y2 or y3. It is going to be A upon A whole square. A is amplitude individually. Capital A is combined amplitude. Now put the values. Fine. What is the value of A? Root 2 plus 1. Solve it. So from here you will get 3 plus 2 root 2. That is E resultant upon E single is equal to 3 plus root 2 root. Fine. Or you can say E resultant is 3 plus 2 root 2 times of E single. So let's try to analyze this. C. The energy associated with the resulting motion is 3 plus 2 root 2 times the energy associated with any single motion. I hope that is also clear. So the question is not difficult. Yes, up to some extent you can say some long approach is associated, and that too is also not long. Reason, we are just using a basic concept that we learn in this particular chapter. Fine. So now let's clean up the board for the new problem, just to enjoy that second problem. This is your question number 9. Slightly big one, but not because it is difficult, that's why it is big one. It is just because of the reason that the problem is because the space is little, that's why it is like that. So let's try to understand it. Two independent harmonic oscillators. I hope this red mark is visible to all of you. Fine. So two independent, this independent term is important over here. I am not going there just because I don't want to hide this place. That's why I am using this red arrow. So now two independent harmonic oscillators of equal masses are oscillating about the origin with angular frequencies omega 1, this omega 1 and omega 2, fine, and have total energies E1 and E2. So for two motions, two things are given. The variation of their movement of P, mv, P with positions x are shown in the figures. If A upon B is equal to n square and A upon R is equal to n, then the correct equations is R. So now this question again the same category, maybe option 1 correct, maybe option 2 correct, something like that. Fine. So now this question is slightly, you can say, difficult from this aspect that it is not easy to visualize what exactly has been explained. Fine. So what I will do, obviously as such no space is here, so I will use this space and then I will explain you what are the correct equations. Basically you have to find the relation between energy and angular frequency. Fine. So this simple approach is here. Let me allow to write down. For the time being, I am going to hide all these things. This is the energy E1, this is the energy E2, this is radius R, this is AB. Now it is nothing but what exactly the shape is visible, fine, and elliptical approach, and this is circular. So it is a specific case of this situation when major axis and minor axis both are equal to each other. So what exactly the situation? That is E1 is equal to half m omega 1, half m omega 1 square a square. Fine, just some time back we mentioned this formula, and it is given in the problem as b square upon 2m, b square upon 2m. We can write it like this. Say this is equation number 1. Fine. One more thing, we should incorporate over here the given value a upon b is equal to n square. So a upon b is equal to 1 upon m omega 1 is equal to n square. Now say this entire is equation number 1. Okay, a upon b as given, that is 1 upon m into omega 1 is equal to n square. Similarly, I should use a blue chalk to write down E2 equation. E2 is equal to 1 by 2 m omega 2 square r square, fine, that is r square upon 2m. Yes, I hope it is correct. Half m omega 2 square r square is equal to r square upon 2m. So now what I can write down, m omega 2, yes, that is m omega 2 is equal to 1. This is equation number 2. So now two different colors I mentioned these two equations. Now from equation 1 and 2, W2 upon omega 2 upon omega 1 is nothing but n square. So let me write down this term over here itself. From 1 and 2, from 1 and 2, omega 2 upon omega 1 is equal to n square. Fine. Now use the values, E1 upon E2 is equal to omega 1 upon omega 2. So let me allow to write down these values. I will not erase out E1 and E2 because I have to put the values in these relations. So E1 upon E2, obviously we are playing with equation 1 and 2. E1 upon E2 is omega 1 upon omega 2 whole square, fine, and a by r as given in the problem, a by r whole square, fine. So once you solve it, you will get 1 upon n square into omega 1 upon omega 2 into n square. Okay. So ultimately E1 upon E2 is equal to omega 1 upon omega 2. So now if you analyze the situation, you will say B omega 2 upon omega 1, just 2 minutes back we calculated, it is still present in your video, that is B is correct, and this is in front of you clear, E1 upon omega 1 is equal to E2 upon omega 2. So this option number D is correct option. Approach I explained. The problem is not a difficult one, but yes, up to some extent visualization is required. So if you are dreaming about IIT campus, if you want to become IITian, obviously you have to do some hard work, fine, and then getting into IIT is anyway not a difficult aspect. This is something which I am saying on the basis of my own experience. Fine. Now, let's move ahead for question number 10 over here. Fine. Again, a small question, very carefully I selected for your understanding. Very simple. I am saying simple because some sort of mathematics, trigonometry is involved, and you are preparing for IIT JEE Advanced pattern. So that is just a child's play for you. Consider the situation. Function x is equal to a sin square omega t plus b cos square omega t plus c sin omega t cos omega t represents SHM. Okay. Now, basically the question is this way. Here a function is given. You have to find for what situation, under what circumstances this will represent a simple harmonic motion, and those incidents, those circumstances are these four. Fine. So what we will do, obviously I will not explain you all four, I will just explain any one of it. Hopefully you find yourself very comfortable. C barabar 2b. Fine, you can do that. C is equal to 2b. Now x is equal to this entire equation, a sin square omega t plus b cos square omega t plus c sin omega t cos omega t. What I am going to do here, I am going to write down this equation in a more simplified fashion. That is, x is equal to b cos 2 omega t by replacing this value plus b sin 2 omega t, and yes, that will give you root 2b sin 2 omega t plus pi by 4. B cos 2 omega t plus b sin 2 omega t root 2 b sin 2 omega t plus pi by 4. Yes, correct. You can replace these values. Equation of SHM with A is equal to root 2b. What is A? A is a resultant amplitude, and that resultant amplitude is given over here. Fine. So now if you just try to check it, then you can say this B is the correct option. Okay. We pick this particular one and then we try to solve it. Yes, we achieved this value. So this B, yes, mod you can use so that there will not be any confusion about the negative positive sign. Similarly, you can check other conditions like C and D. So let me mention over here that not only B, which I proved, is correct, but also D is also correct. What I am thinking, rather than solving you, I should just request one thing. D is correct, that I am telling you. You just write, just 2 steps. At least by that method, definitely you will have to do something, because if I will solve, you just have to watch it. So approach I explained you, what exactly the question is asking I explained you, and these type of questions are very common question, because by this type of question they can check your 2-3 things. I mean, how comfortable you are with basic formulae, calculations and visualization, because this equation which I mentioned, I not solved 2-3 steps which are required previous that. So how much you can visualize, that is something that you can also find out. Fine. So deliberately I am not providing you, I am just saying D is also correct, B I proved. Try yourself. Fine. Just 2 steps are required. So with this small homework type of thing, I would like to close this second episode of this serial. Again, third episode and so on will come back very soon. Till then, keep revising, take care of yourself. Thanks a lot.